Welcome everybody to another homework example video. In this one we'll be looking for to reparameterize a curve with respect to arc length. And so the curve that we're given is r of t is equal to 3 minus 3t squared and 4t squared. And that's going to be good for t greater than or equal to 0. So how this will go, well, we look at our x value. So x is going to be 3 minus t squared, y is going to be 4t squared. So if we look at the derivatives of those, we get negative 6t and 8t respectively. So if we compute our arc length form, then we have the square root of dx dt squared plus the square root of dy dt squared dt. So plugging those values in and simplifying, we get a value for ds of 10t dt, and that's going to work for t greater than or equal to 0. Now our function s is then given by the integral from 0 up to t of our arc length form, our 10x dx. So notice that we've just switched over to the variable x, because inside the integral it's just a dummy variable. And so our variable of time is the one that we're interested in up here as the upper limit. And so if we go ahead and do the integration for that, the integral of 10x gives us 5x squared from 0 to t, and that's going to end up giving us a function of s of just 5t squared. Now this is the function that we want to be able to invert, and so we just take this expression, solve it for t, and we get t is equal to the square root of s over 5. Now if we want to go back and reparameterize our curve with respect to s, then we just take this expression for t, plug it back into t in the original curve parameterization, so we get 3 minus 3 times the quantity, square root of s over 5 squared, and 4 square root of s over 5 squared, and that simplifies to just 3 minus 3/5 s and 4/5 s. So this has kind of been a little bit of a straightforward, easy calculation for reparameterizing with respect to arc length. So let's catch you guys at the next homework example.